Okay, let's start the session. So, once again, yeah. Hello everyone, welcome. I hope you all are doing good. I am Sambhav, your senior math teacher. Today we are gonna talk about some applications of trigonometry. So in the previous chapter, we have seen what is trigonometry, what are trigonometric ratios, what are trigonometric identities and everything, correct? Now in this chapter, we are gonna apply those trigonometric ratios in real life situations, and we are gonna find the heights and distance between two objects or two things. Okay, so I'm gonna wait for just 2 or 3 minutes so that everyone can join. Then we are gonna start the session. And let me tell you one thing, if you are having any doubt, any problem related to this chapter, you can ask us in the chat box or in the comment section. We are going to take your problems, we are going to solve them, don't worry. So you can use the chat box and you can let us know what difficulties you are facing in this chapter. But before jumping into this chapter, I will suggest you to please look for that introduction to trigonometric videos first, so that you will understand what is trigonometry, what are trigonometric ratios, what is the relationship between different angles with respect to different sides, which side to consider as perpendicular base and everything. So this you need to be done with first so that you can apply those things here in this chapter. So yeah, just waiting for 2-3 minutes so that everyone can join. Then we are gonna jump directly into the chapter. This is very easy chapter. Let me tell you one thing. This is very easy and very scoring chapter. You can easily score from this chapter. At least one 5-mark problem you can expect from this chapter. CBSE usually give one 5-mark problem each year from this chapter. It can be a case study, it can be a problem. So we are gonna consider both things in this video. I'm gonna show you different examples. We are gonna solve them together. Then I will show you one case study also. So I guess it's the right time to start the session then. So as we know, the name of the chapter is Some Applications of Trigonometry. Why we are using some? Because in this standard 10th class, we are going to talk about some applications only, because there are too many applications of trigonometry. Okay. Now, in this chapter, I will again explain some things that are required from the previous chapter. So that's why prerequisite. And then heights and distances is the main part of this chapter. So we are going to deal with height and distances here. Then we are going to summarize the chapter after solving some problems. Okay. Now, prerequisite that I will be explaining what are different things related to trigonometry. So in 10th class, we are majorly dealing with right angle triangles when it comes to trigonometry. Right angle triangle means that one angle of that triangle is exactly 90 degrees. So now suppose ABC is a right angle triangle. So angle B is right angle, means the value of angle B is 90 degrees. So now this is 90-degree angle. Side opposite to angle that is 90 degree is always known as hypotenuse. So I'm gonna write H in short. Now, depending on which angle we are referring to, we can have different names for the other two sides. Like for example, suppose if I'm referring to angle C, this angle, then side adjacent to this angle C, there are two sides which are adjacent to angle C, that is AC, but already we are having a particular name for AC, that is hypotenuse, and then we are having BC. So the other side that is adjacent to angle C is also known as base. Then side opposite to angle C is known as perpendicular. So if we are referring to angle C, then this is the base and this is the perpendicular. But suppose if we are referring to angle A, then which side is base now? Because there are two sides which are adjacent to angle A. AC again, the hypotenuse, and AB. So if we are referring to angle A, then AB will become our base side and side opposite BC will become the perpendicular. Why this is necessary? Why we need to understand this? Because we are going to apply these things, hypotenuse, perpendicular, base, to find the value of different trigonometric ratios. So there are 6 trigonometric ratios: sine, cos, tan, cosecant, secant and cot. These 6 are somehow related to the sides, not the actual length but the ratio. Why ratio? Because we can enlarge or decrease the size of a triangle. If we are not changing the value of angle, then the ratio of the sides will remain the same. So that's why we are going to deal with the ratio, not the actual length. Now, sine value can be found using the formula perpendicular by hypotenuse. Whatever angle you are referring to, depending on that angle, you can see that perpendicular and base can be different, correct? So sine of that angle, suppose in this case angle C is theta. So sine theta in this triangle will be what? Perpendicular AB divided by hypotenuse AC. Whatever their length is, you can find their ratio, and that will be the value of sine theta. Cos theta would be base by hypotenuse. Then tan theta. One thing, when we are going to deal with heights and distances in this chapter, some applications of trigonometry, so majority of the time you are going to deal in terms of tan theta, because tan theta is what? Look at this tan theta. Tan theta is perpendicular by base. When we are dealing with height, so it means we are talking about the vertical distance, correct? When we are talking about the distance, we are talking about the horizontal distance. So perpendicular and base are the two things which usually represent the vertical and the horizontal distance between any two objects. So that's why you are going to deal with tan theta most of the times in most of the problems. Value of tan theta is perpendicular by base. Then cosecant theta is reciprocal of sine theta. So 1 by sine theta, or in terms of ratio, it will become hypotenuse by perpendicular. Secant theta is reciprocal of cos theta. So 1 by cos theta, but in terms of ratio of sides, it will become hypotenuse by base. Cot theta is reciprocal of tan theta. So the value will become base by perpendicular. Now we understood the basic concept, basic terminology, although there are some other things that we need to discuss. Now this table, this is the most important part of this chapter. In the last chapter, I told you that in your rough sheet, in your final board exam, you are going to do one thing. You are going to create this table first, because this table will be very helpful for you. Of course, you can expect 1 5-mark problem from this chapter. Also, there can be some problems which may come in 1 or 2 marks. So almost around 7 marks problem you can solve using this table. So this is very helpful. How to create this? Last time I told you the trick. This time I am telling again. As we can see that the most common angles that we are going to deal with in 10th class are 0 degree, 30 degree, 45, 60 and 90 degrees. Then these are different trigonometric ratios written in the first column. What is value of sine theta when theta is equals to 0 degree? What is the value of sine theta when theta is equals to 60 degree, 90 degree, 45 degree? So using this table, we can find that value easily. There is a trick to fill up this table. What is the trick? First thing, you are gonna write 0, 1, 2, 3 and 4 in front of sine theta. In each cell, you are gonna write these values. Okay, 0, 1, 2, 3, 4. Simple counting, whole numbers. Then you are gonna divide each value by 4. You can do that. Then you are gonna put under root. Done? Now, tell me one thing. What is 0 divided by 4? 0 divided by any number will always result in 0. Under root 0, 0 again. So this is gonna give us 0. So sine theta when theta is equals to 0 degree is 0. Then 1 by 4. 1 by 4 is 1 by 4, but under root 1 by 4 is what? Under root 1, 1. Under root 4, 2. So this is gonna give us 1 by 2. Correct? 2 by 4. We can simplify it further. It will become 1 by 2. But under root 1 by 2 will become under root 1 is 1. Under root 2 as it is. We don't need to use the decimal value 1.414. You can go with the root value also. So this is gonna give us 1 by root 2. 3 by 4 is simplified form, correct? So it will become under root 3, but for under root 4 is 2. So it will become root 3 by 2. 4 by 4 is 1. Under root 1, 1 only. This is going to give us. Now, if you are done creating or putting the values in the first row of this table, then you can do one thing. You can just simply change the order of the numbers that you are getting in sine theta, and you can write those values here in this row of cos theta. Whatever value you are getting here in the last cell, you can write that value in the first cell of cos theta. So 1 we are getting, 1 I will be writing. Root 3 by 2 we are getting in the second last cell, so I will write it in the second cell of cos theta, root 3 by 2. 1 by root 2 and 1 by root 2 are in the same position. Then this 1 by 2, and then this 0 will come in the last cell. So we are just changing the order of the numbers, and then we are writing those values in the cos theta, for the cos theta, correct? Done. Now this is looking very clumsy, no? So let me do one thing. Let me erase this and let me rewrite the values again. But you know the trick now, na? How to find these values? 0, 1, 2, 3 and 4. Divide all the values by 4 and put under root. Then that way you can easily find the values. This will be root 3 by 2 and this is 1. For tan theta is basically sine theta by cos theta, that we know, correct? So we are gonna divide these two. Sine theta by cos theta is gonna give us the value of tan theta. So 0 by 1, any number divided by 0 when divided by any number will result in 0. 1 by 2 divided by root 3 by 2. 2 and 2 cancel. What are we left with? 1 by root 3. 1 by root 2 divided by 1 by root 2, 1. Root 3 by 2 divided by 1 by 2, 2 and 2 cancel. What are we left with? Root 3. 1 divided by 0 is not defined actually. Why it is not defined? Because this is a fraction form, na? 1 divided by 0. Whenever we are writing any number in fraction form, suppose 3 by 5. So what is 3 by 5 basically? 3 by 5 represents that we are considering 3 parts out of total 5 parts, correct? If I am having a fraction 2 by 7, it is representing that we are considering 2 parts out of total 7 parts. How about this 1 by 0? Can we consider 1 part out of total 0 parts? No, we cannot. We don't know how to define this situation. So that's why as of now it is known as not defined. So this will be not defined. In short, I will be writing ND. Now, for cosecant theta is reciprocal of sine theta. So we are gonna do one thing. We are gonna find the value 1 upon sine theta. So again, 1 divided by 0, not defined. Then 1 divided by 1 by 2, it will become 2. 1 divided by 1 by root 2, so root 2. 1 divided by root 3 by 2, so it will become 2 by root 3. 1 divided by 1, 1. Secant theta is 1 by cos theta. 1 divided by 1, 1. 1 divided by root 3 by 2, 2 by root 3. 1 divided by 1 by root 2, root 2. 1 divided by 1 by 2, 2. 1 divided by 0, not defined again. Cot theta is 1 upon tan theta, reciprocal of tan theta. So this will become 1 divided by 0, again not defined. Then 1 divided by 1 by root 3, root 3. 1 divided by 1, 1. 1 divided by root 3, 1 upon root 3. 1 divided by not defined is gonna give us 0. So this you can find using this. 1 divided by 0 is not defined. So just transpose the values. So it is gonna give us 1 by not defined equals to 0. So this is 0. There is one more way to find these three values. Look at this. Whenever you are done finding the value of tan theta, so all the values of cot theta are nothing but these values written in the opposite order. Whatever the first value you can see here, it is the last value of cot theta. Whatever is the second value here, it is the second last value here. Third and third, they are same. Then second last, second last, first. Correct? Also, the same can be done for cosecant and secant theta. They are written in reverse order of each other. So this is how you can create this table, and this table is very useful. If you are not liking my handwriting, so let me show you this. Now looking very good, no? And you can easily create this. It will hardly take 5 minutes of yours, but this can ensure that you are getting at least 5 to 7 marks in your final exam. Correct? So this is helpful, useful, and you will not get confused. Now, after creating this table, you will be very sure of what is value of which trigonometric ratios at what angle. Correct? Even if you are very much aware of the value, but you can make sure you are remembering the correct answer. Okay? Now, before jumping into the problems, I will tell you the different terms that we are going to use in this chapter. First is height. Of course, this chapter is all about heights and distances. So we need to know what is height. Height is the measurement of an object in the vertical direction. So it means basically we are talking about the vertical distance of anything. If something is standing like this, then what is the distance between the foot of that object and the top of that object will give us the height of that object, correct? Now, and distance is the measurement of an object from a particular point in the horizontal direction. Again, suppose someone is standing here. This is a tower, huh? So someone is looking at the tower from a certain distance. So what distance is? The value of the horizontal path or distance in between these two, the person that is looking at the object and the foot of the tower. That is the distance. So it will be measured horizontally and the height will be measured vertically. Now, line of sight. Other than height and distance, we are gonna use this term, line of sight, or even if we are not using this, but still it will be there, maybe in a hidden way. Why? Because we are gonna talk about the top of something, the bottom of something. So to look at something, either we are gonna heads up or we are gonna heads down, correct? Whenever we are looking at something which is having more height than us, then we are gonna heads up, correct? So suppose this is the observer. If someone is looking at the top of the tower, then that person is known as the observer. So this observer, if he is looking straight at, at the eye level, then this line is known as the horizontal line, horizontal level. As you can see here, this line is representing the horizontal level, the line that at which his eyes are. But if he is lifting his head up, then he is making some angle in between the horizontal and the line of sight, correct? Then this angle is what? This angle is known as angle of elevation because he is elevating his head to just look at the top or wherever he is looking at. Now, these two terms we are going to use heavily. Then angle of elevation of an object, I told you, is the angle formed by the line of sight with the horizontal level when it is above the horizontal level. Of course, we can look at something when it is having more height than us, correct? Then only we need to heads up like this. Now, the case when we raise our head to look at the object. Now, the other case can be what? Now, think someone is standing at the top of this tower. It is possible, no, that someone is standing at the top of this tower and he is looking at this observer. He is looking at this guy or some object is there. Maybe a uh, football is there, maybe basketball is there. So someone who is standing at the top of the tower is looking at the object or the observer at the ground level. Then his horizontal level is different now, correct? So this is the new horizontal level depending on where the observer is. Now he is looking in this way, correct? He is not lifting his head up, he is actually looking at the object in this manner, where he need to face down to look at the object. So the angle that he is creating with the horizontal level, the line of sight, the angle that they are creating is known as angle of depression now. So a value of this angle will always be given. If we are having a situation like this, then we must be given the value of this angle. But in case the observer is at the top and the object is at the ground level or at the sea level, then the horizontal level will change for the observer. Also, the angle of depression will also change. Now, one more thing I need to tell you. This horizontal level will always be parallel to the ground level. In any problem, if it is given that the observer is at the top of something, top of a building, top of a tower, or anywhere, is at a cliff or something, then the horizontal level of the observer can be different, but it will always be parallel to the ground level. It will always be parallel. This is very much useful because there we can apply the concept of two parallel lines and a transversal. We are gonna use this concept to find some angles, alternate interior angles and all. Now, the angle of depression is of an object viewed is the angle formed by the line of sight with the horizontal when it is below the horizontal level, because the horizontal level is now at the top of the tower. In case when we lower our head to look at the object, when we are lowering our head to look at the object, then we are not making the angle of elevation, we are actually making the angle of depression. It will always be known as the line of sight. The line or uh, the direction where we are looking at will always be known as the line of sight. Now we are done with the terminology, correct? Step by step method how to approach the problems in this chapter. First thing, we need to draw a clear labeled diagram. Whenever you are given different scenarios, it may be regarding distance between an observer and suppose a tower, it may be regarding a cliff and boat example, it can be anything. If a problem is coming from this chapter, then the first thing that you will be doing is creating a very well labeled diagram. You are gonna explain everything, what label is representing which thing, okay? Second step, you need to identify the angles which are given. Sometimes they are not given directly, they must be given in some hidden way, okay? You need to identify them. Height, distance, if they are given, you need to identify them. Then choose appropriate trigonometric ratio. Of course, this is important. When we are given, suppose this scenario is given, this one, observer is here, tower is here, correct? Now look at this thing, the triangle that they are making is this, correct? We are talking about the uh, height and distance. We are not gonna include this line of sight in most of the problems. So we are dealing with the perpendicular because this is the angle of elevation, correct? So this is the side that is adjacent, so base. This is the side that is opposite, so perpendicular. So we are majorly dealing with perpendicular and base side, correct? So which trigonometric ratio we can apply here? We can go for directly tan theta or cot theta. So most of the time you are gonna use tan theta in your problems, okay? So here we need to choose appropriate trigonometric ratio. If suppose in any problem either of the base or perpendicular is not given, but the length of hypotenuse is given, then you need to choose the trigonometric ratio accordingly. It can be sine, it can be cos, Most of the time we are going to deal with these three only. Then substitute the values, because you know the value. Suppose angle is given and we are talking about 1030 degree. So I'm going to do one thing. I will be looking at the table that we have created earlier. What is 1030 degree? Okay, 1 by root 3. Okay, this is the value. I'm going to put that here. Then one value is known to me out of perpendicular and base. We can easily find the other value. Then substitute the values, solve the problem, and write the answer with the correct units also. This is also important. Sometimes we can find the numeric value, we can find the magnitude, but we will not write the correct unit. Examiner can deduce half or 1 mark from your answer sheet. So that's all about the introduction of this chapter. What are the basic things that you need, the table, how to create it, the basic terminology and everything. Of course, this is understandable, but still, if we are not solving problems based on these things, we are never going to understand the concepts clearly, correct? So we are going to do one thing. We are going to take a 3-minute break. After this break, we are going to solve different problems based on this chapter. You will love it. Okay. So yeah, please take 3-minute break. I will come back in 3 minutes. Okay, we are back. Now, as of now, we understood the basic terminology, how to create the table that we are going to use. So it's the right time to jump into the problems. I will explain everything, how to approach the problem, what is the easier way to solve the problem, how to create the label diagram. So I will tell you. Okay. Now, the first problem, the statement of the problem is the angle of elevation of the top of a tower from a point on the ground is 30 degree. Okay. The distance of the point from the foot of the tower is 10 meter. Find the height of the tower. So first we need to analyze the problem. What is given to us? Okay, what is given? The angle of elevation of the top of a tower. If we are talking about the angle of elevation, then observer is at the ground level, correct? He is not at the top of the tower. Then only he is able to create the angle of elevation. Otherwise, he would have been creating angle of depression. First thing, of the top of a tower from a point on the ground is 30 degree. So now we are gonna do one thing. First, we are gonna draw a tower. So here we don't need to actually draw the tower. We can go with the line segments. Okay. So as the height of the tower is not known to us, so we can roughly create one line like this. Why I am creating line like this, not like this? Why in a vertical manner, not in horizontal manner? Because a tower will always be like this only, no? So this is my tower now. Then this will be my ground level. You can use your ruler or scale and pencil or black pen to create this label diagram. Very neat and clean diagram you must be creating. That will impress the examiner. Whoever is gonna check your answer sheet, na, he will get impressed because of the neatness of the diagram. Okay, no cutting allowed. Now, even if you are making any mistake, you can use the diluter or the whitener. Now we are having tower. The second point is that the angle of elevation of the top of the tower from a point on the ground is 30 degrees. So we need to consider one point. Suppose this point. So from this point, if someone is looking at the top of the tower, then the angle of elevation is 30 degree. So you need to join this point with the top of the tower using a ruler again. So this is A, this is B, and you're gonna write everything. AB represents tower. Okay, this point is point C. C is the point from where we are observing the tower, and the angle of elevation that is given to us is 30 degrees. So this is 30 degrees. You will write 30 degree here. The distance of the point from the foot of the tower is 10 meter. Now what is given to us? The distance of the point C, from the foot of the tower. Where is the foot of the tower? Point B. So this distance is 10 meter. So BC is given, not AB, correct? Because, and also not AC. So we need to find the height of the tower. So this is 10 meter. So you will write 10 meter here. Now you can do one thing. You can either directly go with AB, AC, BC like this, or you can give them some very specific name. As we need to find the height of the tower, what I will usually do is I will consider this to be H, height. Okay. Now let AB be equals to H. Analyze the situation now. Which trigonometric ratio should we apply here? Okay, what do we know? Angle we know, correct? In this triangle, look at this triangle ABC. This is 90 degree. Huh? This will always be right angle triangle. This is hypotenuse. This is base because this is the side adjacent to the given angle, and this is perpendicular. We need to find the value of perpendicular. We are given the value of base. So we can use this ratio, which is having a relationship between perpendicular and base. So which trigonometric ratio deals with perpendicular and base? Tan theta, correct? So we can use tan 30 degree and then we can find the value of H. What is tan 30 degree? So you need to write in triangle ABC. Tan 30 degrees is equals to perpendicular by base always. What is perpendicular? Perpendicular is AB or H, because we have given one very specific name to AB, that is H, divided by base is BC. What is the value of BC? 10 meter. So it is basically 10 H by 10. Do we know the value of tan 30 degree? I do remember it. It is basically 1 upon root 3. Even if you are aware of the value, but you want to be double sure that you are remembering the correct value or not, you can do what? You can look at that table that you have created in the rough sheet, correct? Using that table, you can easily tell the value of tan 30 degree, that is 1 upon root 3. So basically what we are saying is that tan 30, in place of tan 30, I will write 1 upon root 3, and this value is equals to h upon 10. We can do one thing, we can transpose this 10 to left side. So it will become 10 by root 3 is equals to h. Now this can be your answer. The height of the tower is 10 upon root 3, but usually we don't keep our answers like that, like this, where we are having an irrational number in the denominator. We can do one thing, we can rationalize this. Rationalize how? We are going to multiply the whole value by root 3 by root 3. That will not change the overall value of the equation, and also it will look nice. So when we are multiplying this value, so h is basically 10 upon root 3, correct? Multiply and divide with root 3. So h value will become 10 into root 3, 10 root 3. Root 3 into root 3, 3 meter. So this is your answer now. So height of the tower, in the end, you will write it like this. The height of the tower is 10 root 3 divided by 3 meters. This will be your final concluding statement. Whatever is asked, you need to write that very clearly. Okay? This is very easy problem. I will be starting from very easy problem to a difficult one. Okay? Second problem. The angle of elevation of the top of a building is 45 degrees. The distance from the building is 20 meter. Find the height. So again, similar type of problem. What is given to us? The angle of elevation, it means the observer is at the ground level. Of the top of a building is 45 degrees. So let's consider a building. So this line segment AB is representing the building. This is my ground level. Now, the angle of elevation of the top of a building is 45 degree. So now, there is a point, suppose this one, from where the angle of elevation of the top of the building is 45 degrees. So this value is 45 degrees. This is my point C. Now, the distance from the building is 20 meter. So it means B and C are 20 meters apart. We need to find the height again. So I can consider value of AB to be h. So you are gonna write everything. AB represents tower. Then C is the point from where we are observing the tower. The tower. Also, given angle of elevation is 45 degrees, and the distance between B and C is 20 meter. Now, in the next line, you will write, let AB be equals to h. Again, one angle is given and the side adjacent to that angle, the value is given 20 meters. Side opposite, we need to find the value of that side. So with which trigonometric ratio should we go with? we should be going with which trigonometric ratio? We are dealing with perpendicular and base only. So again we can go with tan theta, correct? So here in this case theta is 45 degrees. So in triangle ABC, tan 45 degrees is equals to perpendicular by base. Perpendicular here is AB, base here is BC. AB is H, BC is 20. Now, do we know the value of tan 45 degrees? Yes, we know the value of tan 45 degree. It is 1. But just to be double sure, we can just look at the table that is that we have created at the back of the answer sheet in the rough sheet, correct? So from there, we are sure that the value of tan 45 degrees is 1. Now, in place of tan 45, I will write 1, and this h by 20 will remain as it is. Now we just need to do one thing. We just need to transpose this 20 to right side. So from here we can find that the value of h is 20 meters. In the end, you will conclude your answer by writing that the height of the given tower is 20 meters. And please don't forget to mention the correct dimension. Okay, sorry, correct unit. So this is how you can approach this type of problems. Now, this time we are gonna see a problem where we need to apply the logic differently, a little bit. Now, from the top of a cliff, 50-meter high. So it means we are talking about a cliff which is having a height of 50 meters. The angle of depression of a boat is 30 degree angle of depression. This time we are seeing a new term, correct? Angle of depression. When can we create angle of depression? When observer is at a higher distance vertically than the object, correct? Observer is at a higher distance or is at height or more is sitting at the top of something and looking at the other object by lowering his head, correct? So someone is looking at the boat from the cliff. The angle that he is making with the horizontal level is 30 degrees. Find the distance of the boat from the foot of the cliff. Okay. First thing, we need to create the cliff now. So here I will do this. Suppose this is the cliff. This is the top of the cliff. This is the water level or ground level. Now, the height of this cliff is given as 50 meters. So I will write 50 meters. This I will consider as A, this point as B. You can go with any name, but usually we go with A and B. Now, the angle of depression of a boat is 30 degree. So, the horizontal level here is different now. So, this is the horizontal level. Correct? Suppose boat is somewhere here. So, line of sight will be like this. So, this is 30 degree, the angle of depression. This angle is given to us. Suppose this is point C. I told you initially that if angle of depression is given, then horizontal level will always be parallel to the ground level or water level. Correct? If these two lines are parallel, suppose this is P. If AP is parallel to BC, then AC will act as a transversal. Correct? You need to write it like this. First, you are gonna define everything. AB is representing cliff. Cliff. Then C is the point where boat is. Then AP is the horizontal level. Now AP and BC are parallel to each other. Also, AC is acting as a transversal. In between two parallel lines, if a line is acting as a transversal, then they will be creating some very specific angles. Those angles can be equal to each other, right? Now, look at this and this line. This AC is acting as transversal. So this angle and this angle, are they equal? Yes, they are. So you will write, therefore, angle C is equals to 30 degrees because these two angles are alternate interior angles. In case of two parallel lines and a transversal, alternate interior angles are always equal to each other. Then you will write 30 degrees here. Now we are sorted. I can see one triangle ABC. Okay, one thing I know, angle I know. We need to find the distance between the foot of the cliff and the boat. So basically we need to find the distance of BC. Let us consider BC to be X. I will usually use H for heights and X for horizontal distance. Okay. Let BC is equals to X. Now, in triangle ABC, ABC it is. Again, we are dealing with perpendicular and base. So, I will use tan 30 degrees. Tan 30 degrees is equals to perpendicular AB by base BC. AB by BC. AB is equals to 50 meters. So 50. BC is equals to X. What is tan 30 degree? If you know the value, well and good. That is 1 by root 3. If you don't know the value, look at the table that you have created. Now, we know the value of tan 30 degree. So it will be 1 by root 3. 1 upon root 3 is equals to 50 by X. So we can transpose the value, X will come on the left side, root 3 will go to the right side. So X will be equals to 50 into root 3 meters, whatever unit is given to you. So here it is given as meters. So the distance between, concluding line, the distance between the foot of the cliff and the boat is 50 root 3 meters. No need to rationalize here because the irrational value is written in numerator, correct? So this will be your final answer with concluding line. Please don't make any crossing mistakes or any cutting and anything. Create very neat and label diagram. Tell everything what you are considering to be. If AB is the cliff, AB is cliff, right? If C point is showing the position of the boat, boat it is, the angle of depression and everything. So you need to create very well labeled diagram and label you need to explain. Then you can find the answer accordingly. And one thing you can use that is very useful is the table that you have created. Now, fourth problem. The angles of elevation. Now look at the term. Not angle of elevation, angles of elevation. So here we are talking about multiple angles. The angles of elevation of the top of a tower from 2 points, correct? Then only we are having two angle of elevations on the same side of the tower and in the same straight line are 30 degrees and 90 degrees. This is very important. We are talking about 2 points, so it can be anywhere on either side of the tower, correct? Anywhere. Now, in the problem, it is given that they are on the same side of the tower, okay? Also, they are in a straight line. Then, the angles are 30 degrees and 60 degrees respectively. If the distance between the 2 points is 10 meter, okay, find the height of the tower. This is very interesting problem. This type of problems you can expect in your final exam. The first three problems are just for the base, just to let you know what to expect or how to approach the problem. But this type of problems can appear in your final exams. Okay. First thing, we need to create tower. Now, this is my tower. This time we are dealing with 2 points. So two angle of elevation. So I will create the ground first. And please do use scale, ruler and pencil or black pen. Now, this is my tower. Let me name it as AB. 2 points we need to consider. So, first, second. Now, the angles are 30 degree and 60 degree. Now, this is point C, this is point D. Okay, let me ask you one thing. Which angle is 30, which angle is 60? If we are looking at the angle from a very far distance, then the value of the angle is lower. So this is 30 degrees. Correct? If I'm going towards the tower, then I will be elevating my head. Correct? So more angle I am creating. So this will be 60 degrees. Now, if the distance between the 2 points is 10 meter, okay, which 2 points? Which 2 points are we talking about? BC, CD, DB? The 2 points from where we are looking at the top of the tower. Those 2 points. So it means the 10 meter is the distance between C and D. 10 meters only, no? Yeah. So this distance is 10 meters. This distance is not given to us. The height is not given to us. Find the height of the tower, and we need to find the height of the tower, that is AB. Correct? As I told you, in case of heights, I will always use the variable h. But also we need to deal with this distance also, no? So I will use x for this distance. Again, we are gonna do one thing, the approach, how to approach this type of problem. See, using triangle ADB. ADB is also a right angle triangle. I can find the value of tan 30 degrees, correct? That way I will be creating a relationship between the height of the tower and this total distance. Then using triangle ABC, I can again use tan 60 degree value, and that way I will be creating a relationship between the h, this height and this distance. Now in these two equations, one thing is common, that is value of height. Then we can substitute the values accordingly. We will be getting a value of x. Using the value of x, we can find the value of h. That will be my approach. Now, first thing, you're gonna do one thing. In your exam sheets, you will be writing AB represents tower. C is the point from where we are looking at the top of the tower, and the angle of elevation from point C is 60 degree. D is the point from where we are looking at the tower, top of the tower, and the angle of elevation is 30 degrees. Also, the distance between C and D is 10 meters, given part. Now, we are considering the height of the tower or AB to be h. Then you will write the distance between the foot of the tower and point C we are considering to be x. After writing everything, after explaining your figure, you will do one thing. You are gonna write in triangle ABC. In triangle ABC, we can apply tan 60 degree, correct? Because we are dealing with perpendicular and base. So tan 60 degrees is equals to perpendicular AB by base BC. So I am directly writing, but in your exam sheet, you will write everything AB by BC, then you are gonna substitute the values. Now, tan 60 degrees is what? Root 3. But if you are not sure, and if you want to be double sure, you can look at the table that you have created. So, this is root 3 is equals to h by x. From here I can do one thing, I can find the value of h. H will be equals to x into root 3 meters, or no need to write the unit here. This will be my equation number 1 because we are not getting any particular magnitude here. So I will call it my equation number 1. Then I will look for triangle ABD, the bigger one, this one. In this triangle, we are having the value of angle of elevation 30 degrees. Also, we know this distance DC. X, we already assumed that this is the distance between B and C. And H we need to find, so we will go with H. So tan 30 degrees is equals to perpendicular AB H by base BD. What is the total length of BD? This value we know, 10 meter. This value we don't, but we assume it to be x. So the total distance between B and D is what? X plus 10 meters. So you will write x plus 10 here. Now, tan 30 degree value is 1 by root 3. Not sure? Look at the table. 1 upon root 3 is equals to h by x plus 10. Now you can transpose this x plus 10 to left side. So from here we can get the equation in terms of h as x plus 10 divided by root 3. This is equation number 2 now. Now we are having two equations in terms of h. So both are values of h only. So we can equate them. So you will write like this. From equation 1 and 2, x root 3 is equals to x plus 10 by root 3. Transpose this root 3 to left side. So it will become x root 3 into root 3 square, that will be 3. So it will become 3x equals to x plus 10. This x I can bring to left side. So it will become a negative term. So 3x minus x, 2x. So this is gonna give us 2x equals to 10, or simply x equals to 5. So the distance between C and B is 5 meters. But our work is not done because we need to find the height of the tower. So I can use the relationship. Which relationship? Either this one, either this one. So this one is looking simpler, no? So I will go with equation number 1. In equation number 1, put value of x. So this is gonna give us x into root 3, or simply h is equals to 5 root 3 meters. Now you are gonna write concluding that the height of the tower is 5 root 3 meters. So this way you can approach this type of problems where two angle of elevations are given, the distance between the points are given, not the distance between one point and the cliff, or sorry, the foot of the tower, and also the height is not given, but still we can solve this, correct? So we are gonna create a relationship, we are gonna equate the equations. That way we will be getting value of one of the variable. Using that value we can find the value of the other variable. So that will be our approach here. Now, fifth type of problem. This problem did appear in board's exams once. Now, the statement is the angles of depression, again angles, so it means more than one angle. The angles of depression of the top and the bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 40 degrees. Very lengthy statement, but what is given here? We are given two buildings. One is a small building. The height is given of this building as 8 meter. Okay, this is 8-meter tall building. Then second building is multi-storied building. So the height would be Uh, we don't know as of now. But according to the first line, someone is standing or someone is looking at this building from the top of multi-storied building. So if someone is looking at the top of this smaller building from the top of this multi-storied building, then the angle of depression that he is creating, so angle of depression means this is the horizontal level now, correct? So the angle that he is creating is 30 degrees. If he is looking at the top of the building, smaller building, from the top of multi-storied building, then the angle of depression is 30 degree. But he is also looking at the bottom of this smaller building. So now the angle of depression that he is creating is different. It is 45 degrees. So this angle is 45 degrees. Now, find the height of the multi-storied building. So we need to find the height of this building and the distance between the two buildings. We need to find the distance also. You don't need to create these type of buildings in your exam. This is just for your imagination. I just wanted you to understand the situation, what is happening here. The kind of diagram that you will be creating or kind of figure that you will be creating will look something like this. Here, this PC is representing the multi-storied building. One second. AB is representing the smaller building. The height of AB is 8 meters. Now, and you are gonna write everything in the answer sheet like this, that PC is representing multi-storied building. AB is representing the smaller building of height 8 meters. Then the angle of depression, this PQ is horizontal level now. Now the angle of depression or the value of QPB represents the value of angle when the observer is looking at the top of the smaller building from the top of the multi-storied building, and the value is 30 degrees. Also QPA represent the angle of depression when the foot of the smaller building was observed by the observer from the top of the multi-storied building. So this will be your diagram. Also you can join B with D and A with C. So to close this figure, we need to find two things here, value of PC and value of AC. But before that, we need to analyze some situation here. Horizontal level PQ is parallel to BD. Why? Because BD is parallel to the ground level, correct? This line that we are creating is parallel to this ground level AC. Now, this will be what? This will be rectangle, correct? And the opposite sides of the rectangle are what? Equal. So if it is 8 meters, then DC is also 8 meters. One thing. Also, BD and AC are parallel. We know that horizontal level is always parallel to the ground level. So PQ is also parallel to BD. Now, if these two lines are parallel, PQ and BD, then PB will act as a transversal now, and the angles they are creating must be having some very specific relationship. So this angle and this angle, they are alternate interior angles, so they are equal to each other. So this angle is also 30 degrees. Same goes for PQ and AC. They are parallel lines and PA is acting as a transversal. So it means this angle and this angle, they are equal because they are alternate interior angles. Now observe two triangles now, PBD and PAC. In these two triangles, what do we know? We don't know the height of this or the length of this PD. So we will assume it to be H. We also don't know the length of AC or the distance between the two buildings. So we will consider it to be X. But we know the value of this 8 meters, and because of this we know the value of DC also 8 meters. how to find the height or the distance now. First, we are going to consider this triangle PBD. So I will write in triangle PBD. We are talking about the perpendicular and the base of this triangle, correct? So if AC is x, then BD is also x, correct? Because they are equal. So in triangle PBD, tan 30 degrees is equals to PD or H by BD or X. Value of tan 30 degree is 1 upon root 3. 1 upon root 3 is equals to H by X. You can transpose the values and you will realize the value of X is root 3 H. This is equation number 1. Now, look at this triangle, the bigger one, PAC. In this triangle, we can find the value of tan 45. Although one part of this total height is known to us, but this is completely not known. Still, we can create the relationship. So tan 45 is equals to PC, that is H plus 8 meter total height, divided by AC, that is X. Value of tan 45 degree is what? 1. Not sure? You can look at the table, that is 1. So 1 is equals to H plus 8 by X. Transpose this to left side. So value of X is H plus 8. This is equation number 2. So in equation number 1, we are having one value of X. In equation number 2, we are having the other value of X. We can equate them. Yes, we can. So we are going to equate the values. So you are going to write from equation 1 and 2. Root 3H is equals to H plus 8. Now, you can do one thing. You can transpose this H to left side because they are like terms. So it will be root 3H minus H is equals to 8. We can take H common. So it will become H into root 3 minus 1 is equals to 8. From here, the value of H that we are getting is 8 divided by root 3 minus 1. So the value that we are getting is H equals to 8 divided by root 3 minus 1. So I'm going to use the next slide for this one. So H is equals to 8 divided by root 3 minus 1. You can stop here, but as I told you, if you are having any irrational value in the denominator, so you can do one thing, you can rationalize the denominator. How to rationalize this? We can multiply and divide the same number with root 3 plus 1. Root 3 plus 1. Now, 8 into root 3 plus 1, same value. 8 and in brackets, root 3 plus 1. But here what is happening? A minus b into a plus b. A square minus b square. So root 3 square, 3 minus 1 square, minus 1. This will become 2. So H is 8 into root 3 plus 1 divided by 2. We can cancel. So value of H will be 4 into root 3 plus 1. This is your height of the tower, of the multi-storied building. So now you can write that the height of the multi-storied building is 4 into root 3 plus 1. But is our work done? No, because we need to find the distance between the two buildings. We need to find this also. So one relationship we know, that X is equals to root 3 into H, correct? We know the value of H, so we can directly use this. So, okay, this is I'm going to use. X is root 3 into H. So it will be x is equals to root 3 into 4 into root 3 plus 1. So I can directly take this root 3 and will multiply with values that are inside the bracket. So it will become root 3 into root 3. So the x value will become 4 as it is inside bracket, root 3 into root 3 square, that is 3, plus 1 into root 3 meters. So this will be your distance between two buildings. So you are going to conclude it like this: the height of the multi-storied building is 4 into root 3 plus 1 meters, and the distance between the two buildings is 4 into 3 plus root 3 meters. So this is how you can solve this type of problem. This problem, if you are solving this type of problem, it will give you confidence. You are gonna solve every other problem. These problems are easy. You just need to practice how to approach the problem. Then they are very easy to solve. You are just doing the basic calculations here. Now, next problem. At a point on the ground level, the angle of elevation of a vertical tower is found to be such that its tangent is 5 by 12. I don't know why I am saying target. Now, this is a very different type of problem. Here, what is not given to us? The value of angle is not given. Instead, in the statement of the problem, it is saying that the tangent from a particular point, the value of the tangent is 5 by 12. So we need to analyze this line. Also, on walking 192 meters towards the tower, the tangent of the angle of elevation is 3 by 4. Again, the value of the angle is not given, but the value of tangent is given from other point when we are walking 192 meters towards the tower only. Find the height of the tower. So the figure would look something like this. Here AB represents the tower. D is the first point from where we are looking at the tower. Okay. The angle is not known to us, so I will consider it to be theta. But whenever we are looking at the top of the tower from point D, the tangent value that it is making is given, that is 5 by 12. How to use this, I will explain. Then the same person is moving towards the tower by a distance of 192 meters. Now, he is making different angle now, correct? But still, the value of the angle is not given. Instead of that, the value of tangent is given again, that is 3 by 4. And we need to find the height of the tower. So again, I will do one thing. We need to find the height. So I will consider the height of the tower to be h. And this distance is also not given, na? BC. So I will consider it to be x. As I told you that vertical distance, I will consider h and horizontal x. Now, how to solve this problem? First thing, again we are dealing with perpendicular and base values, na? So we are gonna go with tangent. And also this is more important for us to use tangent because the tangent of those angles is given, that is 5 by 12. So if I am looking at triangle ABD, after writing everything for you, I am explaining again. You are gonna explain what is what. AB is the tower, D is the first point from where the observer is looking, and the tangent is 5 by 12. Then C is that point where that he is looking at the tower after coming 192 meters towards the tower. So after writing everything, you are gonna write in triangle the first one ABD. Tan theta, because the angle that we are considering is tan theta. Tan theta, what is the value of tan theta? Perpendicular by base. Perpendicular is h, but base is this BD. Total length would be x plus 192 meters. Now, we don't know theta. How to find the value from the table then? No need to use the table in this type of problems because tan theta value is already given, that is 5 by 12. So you can directly put value of 5 by 12 in place of tan theta. So the equation will become 5 by 12 is equals to h by x plus 192. Cross multiply. Of course, I want the whole equation to be in terms of h. So I will just only transpose this x plus 192 to left side. So the equation will become 5 into x plus 192 divided by 12 is equals to h. This will be my equation number 1. Okay, this is my equation number 1. Now, second triangle, triangle ABC. In triangle ABC, again the value of tangent is given. So, in triangle ABC, tan beta is equals to side opposite or perpendicular AB, that is h, by base BC. Tan beta is given 3 by 4. H as it is by x as it is. Transpose this x to left side. So the equation will become 3x by h. Oh, sorry, 3x by 4. My bad. This is not h. This is 4. 3x by 4 is equals to h. This will be your equation number 2. Now you are having two equations in terms of h. We can equate them. Correct? So from equation 1 and 2, let me use this space. From equation 1 and 2, we can see that the first equation is 5 by 12 into x plus 192. So 5 into x plus 192 by 12 is equals to 3x by 4. 4 and 12 are cancelable by 3. 3 I will transpose to right side. So the equation will become, I will open the bracket, 5 into x, 5x, plus 5 into 192, that would be 0, 0, 45, 16459, 960 is equals to 3 into 3x, 9x. Transpose this to right side because they are like terms. So it will become 960 is equals to 9x minus 5x, 4x. So value of x would be 960 by 4. That is x is equals to 240 meters. So the distance between point B and point C is now known to us, that is 240 meters. But still we need to find the height of the tower, correct? So is there any relationship between h and x? So this one is the easier to use, although there are two. No, you can go with any, but I will choose this one, easier to solve. 3x by 4 is equals to h. So in equation 2, put value of x. Therefore h is equals to 3 into the value 240 divided by 4. These are divisible by 60. So value of h would be 3 into 60, 180 meters. Now you can conclude the problem by writing that the height of the tower is 180 meters. So this is how you can approach this type of problem. If the value of angle is not given, but the line is given like this, that the tangent is 5 by 12 and tangent is 3 by 4, then again you can do one thing, consider the angles to be alpha, beta, theta, beta, anything. Then you can do one thing, you can replace the tan theta with this value, tan beta with this value. They are usable. So please don't get confused that the angles are not given, how to approach this problem. Again, everything is given. Now, next problem. This one is also one of the problem that appeared in the exams. A straight highway leads to the foot of a tower. Okay, as you can see, there's a tower and straight highway where the car is running leads to the foot of the tower. A man standing at the top of the tower observes a car. Okay, someone is here at the top of the tower and he is observing the car at top of the tower, observing a car at an angle of depression of 30 degrees. So the angle of depression he is creating with the horizontal. So this angle is 30 degrees. when he's looking at the car, which is approaching the foot of the tower. So it is moving in the direction of the tower. Now with a uniform speed. So this is very important. So the speed is not changing. 6 seconds later, the angle of depression of the car is found to be 60 degree. So the time taken by car from moving from this point to this point is 6 seconds. And the car is moving at a very uniform speed. So speed is not changing. Also, the angle of depression that the man is making with line of sight and the horizontal level is 60 degrees. Now, find the time taken by the car to reach the foot of the tower from this point. What is the major problem here? Angles are given, but no distance is given. Nothing. Not the height of the tower, no distance between car and the tower, or the distance between the cars also. Nothing is given in terms of distance. But one thing is given, that the time taken by the car from this point to this point is 6 seconds. Can we use this? Of course, we are going to use this, because we need to find the time taken by car to reach the foot of the tower. So from this point, how much time it will take to reach the foot of the tower, that we need to find. Let me ask you one thing. The car is moving at a uniform speed. Speed is not changing, correct? Now, whatever time it took from reaching from this point to this point, if somehow we are able to create a relationship between this distance and this distance, then we can find the time taken by the car reaching from this point to the foot of the tower in a relative terms, correct? Because the speed is not changing. So we are going to use this approach only. We are going to do one thing. First, we are going to create a very neat label diagram, not this one. So this is the diagram. AD is representing the tower, BD is representing the, B is the position where the car was initially when the observer was looking. C is the point where he is looking at the car at the second time. The B and C, the distance, the car that is covering, the car is taking 6 seconds. Then we need to find the time taken by the car in covering the distance between C and D. Also, this angle and this angle, they are alternate interior angles, they are equal. This angle and this angle, they are also alternate interior angles, they are also equal. Now, if these are equal, so look at this triangle ABD. In triangle ABD, first, we almost forgot this. AD I will consider as H. No distance is given, so I will consider the BC to be X and CD to be Y. This time one new variable we are using, Y. So now, if somehow I will be creating a relationship between X and Y, I can easily tell the time taken by the car from this point to this point, correct? Now, look at this. In triangle ABD, 10-30 degrees is equals to perpendicular, or H, divided by the base, that is BD. So total length is X plus Y. Now 10-30 degrees, I know 1 upon root 3 is equals to H by X plus Y. Then you can transpose. So X plus Y is root 3 is equals to H. This will be your first equation. From where we can get the equation number 2? From the second triangle ACD. So in triangle ACD, 10-60 degrees is equals to perpendicular, that is H, by base, that is CD. Or now 10-60 degree is root 3 is equals to H by Y. We can transpose, so it will become Y into root 3 is equals to H. This will be equation number 2. From this equation we can, and this equation, I can see that we are having two values of h, we can equate them. So next slide I will be using. From equation 1 and 2. So what are we having? X plus y by root 3. X plus y by root 3 is equals to y into root 3 or root 3y. Now transpose this root 3 to right side. So root 3 into root 3 will become 3. So x plus y is equals to 3y. Transpose this y to right side. So x will become 3y minus y, 2y. Now look at this. X, this was the x value, no? This is y and this is h. X distance is twice as that of y, correct? Or simply y is half of x. The car is moving at a very uniform speed, correct? Time taken by the car in covering x meters is 6 seconds. So to cover x meters, car is taking 6 seconds. Now to cover 1 meter, how much time it will take? 6 by x, unitary method. To cover 1 by 2 of x meters, how much time will it take? 6 by x into 1 by 2 of x. X and x are going to cancel each other. 2 can cancel 6, so it will be 3 seconds. So to cover a distance of half of x meters, it is going to take 3 seconds. So y is equals to half of meters. So the time taken by the car from point C to reach the foot of the tower is going to be 3 seconds. This will be your final answer. So this is how you can approach this problem. No distance was given, correct? Only angles were given. So we are going to create the relationship, and using unitary method, you can find the final answer. So 3 seconds would be your final answer. So we are done with different type of problems that you can expect in this chapter. One more thing we need to consider: case study. Recently, CBSE has been giving case studies in different chapters, for different chapters. So for this chapter, I will be showing you case studies. If you are getting a problem related to case study, you should be feeling lucky, because they are more than easier to solve. So first we need to understand the situation that is given to us in the case study. In this case study, a group of students of class 10th visited India Gate on an education trip. The teacher and the student had interest in history as well. Okay. The teacher narrated that India Gate, officially named Delhi Memorial, originally called All India War Memorial, and monumental sandstone arch in New Delhi. So previously it is having a different name, now it is having a different name. Dedicated to the troops of British India who died in wars fought between 1914 and 1919. So it is a war memorial dedicated to those soldiers who were fighting for British India when India was not independent. Now, the teacher also said that India Gate, which is located at the eastern end of the Rajpath, formerly known as Kingsway, so it is also having two different names, Rajpath and Kingsway, is about 138 feet or roughly around 42 meters in height. So the height of India Gate is 42 meters. This is the scenario, this is the case study, and based on this case study, CBSE will giving you some problem. Problem number 1. What is the angle of elevation if they are standing at a distance of 42 meters away from the monument? To solve these problems, you are going to do one thing. You are going to quickly create a diagram. Suppose here I will be creating the India Gate. This is India Gate. So height of India Gate is 42 meters as given here. Because we are dealing in meters now, so that's why I am using meters value. If it is given in feet, I will be using this one. Now, suppose this is point A, B. Now we need to find the angle of elevation. So suppose the group is standing here at point C. The distance between them and foot of the India gate is 42 meter. We need to find the value of this angle. Suppose this is theta for now. Now we can easily find the value of this angle using the ratio between this side and this side. So this is about perpendicular and base. Again we can go with tan theta. So tan theta is AB by BC or 42 by 42. 1. So tan theta is 1. For which angle, for what value of theta, tan theta is 1? Tan 45 degree. So we can replace this with tan 45 degrees. So both the trigonometric ratios are equal. So it means the angles are also equal. So theta value is 45 degree. So you can easily select B option. That is your answer, 45 degrees. Done with one problem, 1 marks you will get. Next one. They want to see the tower at an angle of 60 degrees. Okay, this is degrees. Huh? So they don't want to know the distance. So they don't want to know the distance where they should stand, and hence find the distance. Okay, they are not having any idea where they should be standing, so that they will be watching the India gate at an angle of elevation of 60 degrees. So this time what is given to us? The angle of elevation. So this is India gate. This angle should be 60 degrees. ABC. This is where the group is standing. Now the height of the India gate is again 42 meters. We need to find the distance of BC. So again tan 60 degrees should be equals to AB 42 by BC. Suppose BC is x as of now, x. Tan 60 degrees is root 3. Root 3 equals to 42 by x. Cross multiply or transpose, x is equals to 42 by root 3. Now the value is not matching. We know that the value of root 3 is 1.73, correct? So if we are dividing 42 by this value of root 3, so okay, this is 2.24 guys. So this will come roughly around 24.24 meters. We need to write the values into decimals, so this will be your correct answer, 24.24 meters. Then next problem. If the altitude of the sun is at 60 degrees, then the height of the vertical tower that will cast a shadow of length 20 meters. This is important, this type of problem. Whenever we are talking about the shadow because of sun, or it is given that the sun is at the altitude of 60 degree. So basically what we are talking about, suppose this is one tower, because we are talking about the tower, no, one vertical tower. Suppose sun is here somewhere. So whatever angle that is given in with respect to sun, the shadow will be creating that much angle only. So this is the shadow of the tower and this is the line of sight. Okay, so the angle will be same, that is given here 60 degrees. Now the height of the vertical tower that will cast a shadow of length 20 meters. It means the length of shadow is given 20 meters. So A, B, C. We need to find the height of the tower. So I will consider it to be H. Again tan 60. H by 20. Tan 60 is root 3. H by 20. Then value of H is 20 root 3 meters. These are very small problems. You can easily find the answers. Just apply the basic logic and you can score easily in case studies. Fourth problem. The ratio of the length of a road and its shadow is 1:1. Okay. The angle of elevation of the sun is, okay. Again, when we are talking about the angle of elevation of sun, then it will be same as of this angle, the angle made by the shadow and the line of sight. Suppose ABC. So basically we need to find the value of this angle theta. What is given? The ratio of the length of the road. suppose this is the road, the length of this road and its shadow is 1:1. If this is x, then this is also x. They are of equal value. Then we need to find the angle of elevation of sun. Okay, what is angle of elevation then? So tan theta is equals to x by x, right? Perpendicular by base 1. Tan theta, for which value of 10 it is 1, 1045. So tan theta is equals to 1045 degrees. So theta is equals to 45 degrees. So answer is option B. Now last one, the angle formed by the line of sight with the horizontal when the object viewed is below the horizontal level. What is the name of the angle? The angle formed by the line of sight with the horizontal when the object viewed is below the horizontal level. So someone is standing at the top of a tower. This will be their horizontal level and object is here at the ground level or below the height of this tower. Then if someone is looking at this object, so the angle that they are creating with the horizontal level is known as what? We know this, angle of depression. So the correct answer is angle of depression, option C. So this is how you can approach different type of problems in this chapter. Also how to solve them I told you, and one more thing, remember that you are gonna create the table first. That will be very much helpful. Now the approach we know, how to solve them and everything. So we are done with this session. The case study is very easy, correct? Easier than the problems, and you can easily score 1 mark, 5 marks, because each part will be of 1 marks in case study. So we are done with the chapter and we are done with this session. If you are still having any doubt, any problem related to this chapter, you can let us know in the chat box or comment section. So we'll meet you in one more session with one more chapter. Till then, bye bye. Take care of yourself, and let's summarize this chapter. We have seen the prerequisite where we talked about the trigonometric ratios and everything from the previous chapter, and then we found we understood the concept of height and distances, different terminologies, and how to solve different problems. So yes, we are done. Thank you for joining the session. We'll meet you soon. Till then, bye bye, and I will end this session for now. Thank you.